In today's note, we're going to look at just some general quadratic relations problems, looking at some that require interpreting graphs and others where we're using the equation to figure out certain values on our graph. So in the first example, the height of a toy rocket is represented by the formula or the equation h equals negative 5t squared plus 30t plus 1, where is the height of the toy rocket in meters and t is the time in seconds. So what we're going to do is we're going to use Desmos to graph the relation. So again, Desmos is an app that you can access on the internet, or you can download it as an app on your phone. If you just search Desmos, it should come up. But what we're going to use, we're going to use the online version over here. So if you go to desmos.com, this will come up. You see to the right, just click Start Graphing, and you will be taken to this page here where you can enter in your equation on the side. So we're going to enter in our equation. So we're just going to do y equals, or we can do actually h equals, just keep it similar, negative 5t squared. And again, if you're not comfortable using the keyboard with the little hotkeys, you can show a keypad down here, and this will show kind of the key things. So 2 plus 30t plus 1. And what that does is that graphs our equation over to the right here. So we're going to just zoom out a little bit to get a good view of it so we can see all the key points. So that's our graph. So we've done part A. Part B it says determine the vertex of the parabola and interpret the meaning of the vertex in the context of the situation. So the nice thing about this is that if we click on the graph, we'll see the key points pop up for us. So we just have to click them and they stay there. So that is our vertex. So the vertex of our graph is the point 346. And what does that mean in the context of the situation? Well, in the context of the situation, again, the x value represents the time. So our time is 3. So this means that after 3 seconds, our rocket is, and if we look at the y value, and we know that the y or the t value or the h value, represents the height in meters, that means that our rocket after 3 seconds is 46 meters high. You could also say that the vertex is the highest point. The highest point our rocket will get. Right? There's no other point that's higher than this, so that's the highest. So moving on to the next question. Determine the t-intercept of the parabola. Interpret the meaning of the t-intercept in the context of the situation. So while they're referring to t, this is basically just saying the x-intercepts. But again, because we're using t in the equation, that's why they're talking about t. So the nice thing is, if we look at these, we can see one that's negative and we can see one that's positive. So you could argue that it's basically 6 and we have a negative value. So here, while it's asking for the t-intercept, it's only asking for the t-intercept, so that means it's only asking for 1, but here we have 2 on our graph. We can clearly see 2. What we can do is we can disregard this first one, the negative one, because again, t represents time. We don't have anything in negative time, so we can just disregard that. The reason that it's there is because when we're using the graph, the quadratic continues on forever regardless, so it doesn't really care about time. But when we're reading the graph, we have to interpret it and understand what the values are actually showing. So that's why we disregard the negative time value, and we only refer to the 1. So our 1t value, we're going to round it to 6. So basically it's 60. And what is the meaning of this t-intercept? And again, in the context of a rocket being launched into the air and coming down. So again, the t value or the x value, 6 represents time, so that means that after 6 seconds, the height or the y value, so the height is 0. In other words, you can basically say that it hits the ground. It hits the ground after 6 seconds. Again, if you're picturing a rocket, it goes up, hits the highest point, and then comes down, and then hits the ground. The H intercept, or next question, so we want to find the H intercept and interpret what it means. The H intercept in this case is just our Y intercept. So we're just going to zoom in a little bit just to make it a little bit easier. But we can see that the H intercept is right here at 0 and 1, or the Y intercept. Again, we're just using the graph to click on it and find that. So the Y intercept is 0, 1. What does this mean in the context of our model rocket? So again, X is 0, which means time is 0. So at 0 seconds, the height is 1 meter. Or in other words, what you can say that the initial height is 1 meter. Or you can say that the rocket is launched from a pad that is 1 meter high, or something to that degree, as long as you know that the starting height of the rocket is 1 meter. It doesn't start on the ground when it's launched. It starts 1 meter in the air already. So we're going to move away from the Desmos graph, but again, if you have any quadratic equation or any equation in general, you can enter it into here and then see a visual of it and then be able to interpret the different points and what they mean. But we're going to move on. We don't need the graph anymore. So in example 2, we want to know if the parabola y equals ax squared plus or minus 16 passes through a certain point, what is the value of a? So in this case, what we're going to do, similar to what we've done before with other equations or linear equations, when we're given a point and an equation and we want to find a missing value, we need to sub in the point. So we're going to sub in our point, which we were given, into our equation and figure out what our a value is, or solve for the a value. So in this case, we have y equals ax squared minus 16. My a value, or my y value, again, comes from the point. So 20 equals a, which I don't know, times x squared, which is negative 2 squared now, because I'm replacing the x, then minus 16. I'm going to simplify first. So a times negative 2 squared is becomes a times 4 minus 16. Or I can rewrite this as 4a minus 16. Now I'm going to solve for a, or isolate for a, which is similar to what we've done before in previous units. So I'm going to get rid of the 16 by adding 16. I have to do the same thing to both sides. One side cancels out. I'm left with 36 equals 4a. And to get a by itself, I'm going to divide by 4 on the one side, divide by 4 on the other. One side cancels out, and I'm left with a equals 9, which is my final answer. So therefore, I can rewrite the equation y equals 9 x squared minus 16. Or I can just write therefore the a value is 9. So again, it's very similar to what we've done before with other equations. You're subbing in the point and then solving. So we sub in the point, then we solve for the missing value. So let's look at B. B is the same idea. If we have a parabola y equals 2x squared minus x plus c, and it passes through the point 3, 12, what is the value of c? So again, if we're plugging a point in, or we're going to substitute our point in, we have an x and a y coordinate, or an x and a y value. That's going to go into our equation, 2x squared minus x plus c. y is 12 equals 2 times x squared, which is 3, so 3 squared. Again, remember it only replaces the x. Minus 3, so replace x again, plus c. We have 12 equals 2. 3 squared is 9. Remember the exponent is only on the 3, not on, and we have to follow BEDMAS, so we're not multiplying 2 times 3 first and then using the exponent. Minus 3 stays the same. Again, you may be able to simplify this in shorter steps, but I'm just going to work through it. So 2 times 9 is 18, minus 3 plus c. 12 equals 15 plus c. And now I've done all the simplifying I can. Now I need to start working on canceling things out. So I'm going to get rid of the 15 by minusing 15, doing the opposite. I have to minus 15 from the other side. One side cancels out. I have negative 3 equals c, and this is my final answer. So I get a value for c that is equal to negative 3. So therefore, y equals 2x squared minus x minus 3. And again, if I wanted to, or I could just say, and therefore the value of c, or c equals negative 3. So again, the main things from here is just being able to find missing values if you're given a point. Similar to what we've done before, substitute the point in and then solve the equation for the missing value. And if we're given an equation, can we enter it into Desmos and then interpret what certain points mean? Similar to what we've done before when we were already given a graph.